We are the Center for Biomediated and Bio-Inspired Geotechnics. We seek to develop a new generation of geotechnical engineering solutions to infrastructure development problems, geologic hazard mitigation problems, environmental remediation problems, and natural resource development problems. The CBBG is not just an ASU enterprise. It's an ASU-led enterprise, but we have 3 university partners, Georgia Tech, University of California, Davis, and New Mexico State, who will also play an integral role in the center. And then we have our industrial partner program. And we've been successful in recruiting a very broad spectrum of the stakeholders in developing these technologies. Our goal is to develop methods that are inspired by nature, that sometimes use biological processes and biological materials to achieve the same goal. You know, nature, through 3 billion years of evolution, has developed some really elegant solutions to a lot of the problems that we face in geotechnical engineering, from how we can support buildings better, to make the soil more resistant to erosion or earthquake hazards, to remove contaminants from the soil. And so by studying and understanding these processes, we hope to be able to apply them in an engineered manner to solve similar problems that are associated with infrastructure and the environment. One of the major focus of the initial research projects in the center is the mitigation of earthquake-induced liquefaction. Earthquake-induced liquefaction is a phenomena where saturated sand soil turns into basically a viscous liquid due to the earthquake shaking. Buildings built on this soil will sink into the ground. Tanks buried underground will pop up to the ground surface. Slopes will flow laterally, opening up big cracks in the ground. And it's a source of significant damage in almost every earthquake. There are several biogeotechnical technologies that we'll be pursuing that have the potential for cost-effective remediation of liquefaction under existing structures. Phoenix is an air quality non-attainment zone according to the US EPA, and it's not due to industrial pollution, it's not due to vehicle exhaust, it's due predominantly to wind-blown dust, fine soil particles from disturbed sites that get entrained into the atmosphere and then can create serious health problems. So one of the gratifying aspects of the CBBG is how well it meshes with the principles of the New American University. We're interdisciplinary, we're socially engaged, we'll be involved in solving some of the important problems that affect the East Valley. We're going to create a very diverse group of investigators. We have an educational and outreach program that will get us engaged with the local community, and we're globally engaged. We'll be tackling problems that are important not just to Arizona, but are important around the world.
On May 22, 2019, the Blinn College District joined Texas A&M University system officials as they broke ground on the Agriculture and Workforce Education Complex located on the 2,000-acre Rellis campus in Bryan, Texas. This 38,000 square foot complex provides a state-of-the-art facility where students will prepare for high-demand careers in secondary education and the construction industries. The $15 million facility is the result of a collaborative effort of the Texas A&M system, the Texas A&M University Department of Agricultural Leadership, Education, and Communications, and the Blinn College District. The future home of the Texas A&M Agricultural Science Program will prepare and place agricultural science teachers into high school classrooms across the state of Texas. It also will serve as home to Blinn College's workforce training offerings, including advanced manufacturing, welding, carpentry, and HVAC. The 16,000 square foot building will include 5 demonstration and traditional classrooms, teaching and simulation technology, a seminar room, a computer classroom, faculty offices, and space for students to collaborate on projects. The facility also includes the 11,000 square foot agricultural trades pavilion and the 11,000 square foot construction trades pavilion, which will serve as large open laboratory spaces for students to work on full-scale projects. Expected to be completed in June 2020, The Agriculture and Workforce Education Complex is certain to be yet another memorable milestone in the partnership between the Texas A&M University system and the Blinn College District.
There are approximately 620,000 bridges in the United States. About half of these are over 50 years old, and many are labeled as structurally deficient. With increasing age, more severe environmental conditions, and increased traffic, retaining acceptable performance of our national infrastructure is becoming more and more challenging. Unless timely interventions are undertaken, the annual costs for bridge maintenance and rehabilitation could easily surpass $15 billion. To address this crisis head-on, Rutgers Center for Advanced Infrastructure and Transportation created the BEAST, the Bridge Evaluation and Accelerated Structural Testing Facility, the only facility in the world used for the accelerated testing of bridges. The process is quite revolutionary. Bridge specimens are created and then enclosed in an environmental chamber. We then simulate severe weather and wear and tear from vehicles, allowing us to gather critical data on how prolonged exposure to varying elements leads to bridge deterioration. In just 1 year, the BEAST emulates 10 to 15 years worth of real-world deterioration. This information is invaluable, as it allows us to provide actionable research to state departments so they can better manage funds to improve their maintenance planning and extend the life of their bridges. If a bridge closes, it has an alarming impact on surrounding infrastructure and everyday life. With the safety of our citizens at the heart of our work, Rutgers is leading the charge to ensure the durability of our bridges for years to come.